Good morning, ladies and gentlemen. This is Mrs. Avila presenting your lesson for Earth Science for Tuesday, May 5th. So the meme of the day is whoever threw this away, please pick it up. The weather forecast said it's going to rain and we already have enough going on. If you don't know who that is, ask your parents. I'm sure they saw that movie when they were a child. So today's lesson is titled Investigating Paths of Energy. And our essential question today is what happens when energy interacts with carbon dioxide or methane in the atmosphere? So our agenda is going to be to watch the Screencastify video going through the lesson. That's what you're watching right now. You are going to fill out the Investigating Paths of Energy document. You're going to copy and paste key concept number 12 into the Unit 7 Key Concepts Chapters 2 and 3 document. You're going to complete the Lesson 2.7 assignment. So things that you need to have open right now. You should have the Screencastify video open. You're watching it. You should have the Investigating Paths of Energy document open. You should have the Unit 7 Key Concepts Chapters 2 and 3 document open. And you should have Lesson 2.7 assignment open, okay? Please make sure that you press turn in for your Investigating Paths of Energy document and Lesson 2.7 assignment. Do not turn in or press turn in the Key Concepts assignment. You will be working on this for a while, for a few more days. So, all right, let's go into the lesson. Investigating Paths of Energy is our lesson for today. As I said, the essential question, what happens when energy interacts with carbon dioxide or methane in the atmosphere? Before we get started, make sure that you have this document open. You have your Unit 7 Key Concepts Chapters 2 and 3 document open and Lesson 2.7 assignment document open. So during your research as student climatologists, you have gathered evidence to investigate how different gases relate to energy and temperature. You found that an increase in the amount of methane or carbon dioxide in the atmosphere means that more energy is entering than exiting the Earth system. Now you will figure out exactly why this is happening. So our unit question was, what causes climate change? Chapter 2 question is, why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? So a few days ago, you added a couple of new key concepts to your Unit 7 Key Concepts document. To refresh our memories, here they are. If there is an increase in the amount of carbon dioxide or methane in the atmosphere, my clock is going off. It's 1 o'clock in the morning, or just about. And it never plays the song, and it's going to do it now. Oh, there it goes. It stopped. Okay, so let me restart. If there is an increase in the amount of carbon dioxide or methane, the amount of energy leaving the Earth system decreases. So more energy enters than exits. If there is a decrease in the amount of carbon dioxide or methane, the amount of energy leaving the system increases. So less energy enters than exits. So it's an inverse relationship, meaning that it's the opposite. So if the gases increase, the temperature decreases. If the gases decrease, then the temperature is going to increase. So today we are going to investigate if it is possible for gases in the atmosphere to change the behavior of energy on Earth. So our investigation question, what happens when energy interacts with carbon dioxide or methane in the atmosphere? So let's watch this video.
Your business idea needs a website? So go to Wix.com. What are you waiting for? Today's the day. The Earth and the Moon are basically the same distance from the Sun, yet temperatures on the Moon average an unlivable -18 degrees Celsius, and even deadlier, they range from -170 Celsius during lunar night to 100 Celsius at lunar noon, regularly exceeding both the coldest and hottest temperatures ever recorded on Earth. And while the days and nights on the Moon are about 14 times longer than those on Earth, our planet's relatively fast rotation isn't what spares us from those loony temperatures. What protects us is our atmosphere. By day, it serves as a shield, blocking out the most harmful and energetic of the sun's rays and about 1/3 of the less intense but visible light. At the same time, it traps the infrared radiation, aka heat, radiating out from Earth's sun-warmed surface, keeping us from freezing solid at night. In order for our atmosphere to absorb any kind of radiation, it needs to have some electrically charged particles for passing electromagnetic waves to push around. And most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays. For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder. Thanks so much to the great...
So I like the little game analogy. It kind of shows you, 214 is where I was going to show that. It shows you how that energy is absorbed and gets redirected back to Earth before it can escape.
Outgoing heat. Each captured ray gets pinged around the atmosphere, too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder.
Interesting video. All right. So a vocabulary word that we're going to be discussing today is used when we're talking about energy, where energy goes when it hits carbon dioxide or methane. And that vocabulary word is redirected, which means to send to a new or different place, redirected. All right, so what happened to the Earth system over time? The energy is increasing in Earth's system. Why was energy increasing? Energy wasn't leaving as fast as it came in. Some energy was being absorbed by carbon dioxide and methane, then re-emitted and redirected back to Earth. So this is pulled from Amplify, and it's trying to get us to understand that in the past 140 years or so, why has the temperature increased? well, it's increased because the energy that is being absorbed is increasing, and that energy isn't leaving as fast as it came in. Some energy is being absorbed by carbon dioxide and methane, and then it gets redirected to the surface and heats up the Earth's surface, which raises the temperature. And eventually, some of that energy can get bounced back into space, like in that game in the video, but generally it's warming up the Earth's surface, which warms up the Earth. Now we know that carbon dioxide and methane stop energy from leaving by redirecting energy that would have exited the system back towards Earth's surface. Since carbon dioxide and methane stop some energy from leaving, increased carbon dioxide or methane cause more energy to enter than exit. It's not letting some of that energy exit. So that leads us to key concept number 12, which is carbon dioxide and methane stop energy from leaving by redirecting energy that would have exited the system. So they stop the energy from leaving and they redirect it back to the surface. So it's time to open your Unit 7 key concepts, copy and paste this into your document. So I'm going to highlight or select and I'm going to copy it. And I'm going to go to my key concepts document, which we should have all been working on already, and we know what to do already. You're going to paste that in that document. So we already have 1 through 12 at this point. Then I go back into my document. Lesson continues below. And here we have some screenshots of what is an amplifier. In the two models below, you see that nitrogen dioxide on the left allows energy to pass through it back into space. Our atmosphere is composed of 78% nitrogen. So most energy that enters the Earth will hit nitrogen atoms. That energy just passes straight through it. However, the carbon dioxide can either absorb the energy or redirect it back down to Earth's surface, which results in additional heat energy going back to the surface, raising temperatures. So this is just showing that most energy will pass through nitrogen atoms, no problem, get bounced back, and some of it will go back into space. Whereas if it hits a carbon dioxide atom or molecule, then it's going to be either absorbed or redirected back to Earth, so that energy isn't able to leave when it tries to the first time. So based on all of the reading and investigation so far, which of the following statements is the most accurate claim? You're going to highlight which one you think is correct. A, increased carbon dioxide or methane makes more sunlight enter the Earth's system. B, increased carbon dioxide or methane holds energy in the atmosphere permanently. Or C, increased carbon dioxide or methane redirects some energy that was leaving back to the Earth's surface. So you're going to highlight, which means you're going to select whichever one you think is correct. You're going to click on these three dots, and here's highlight. You're going to highlight which one you think is correct. So which one did you choose? Hopefully you would have chosen C. C is the correct one. It's not making more sunlight enter the Earth system. It's really the energy that's entering. We can't create more sunlight to enter the Earth system. And B is not correct because it says that it holds the energy in the atmosphere permanently. It's not permanently. Some of that energy can escape back into space, but it's like that game in the video where if it's, think of, I can't think of those games. The think of that little marble or ball in the game. It kind of bounces around for a while before it can actually exit. So that energy is being redirected to Earth's surface and absorbed. All right, so chapter 2 question, why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? In the atmosphere, carbon dioxide and methane absorb energy and then redirect it. Then the energy is absorbed by Earth's surface, and this increases Earth's temperature. So a lot of the time, energy is radiating from Earth's surface. It hits the Earth's surface, and then it kind of pings back. When there's carbon dioxide and methane, if that energy hits one of those molecules, then it's absorbed and possibly redirected, like right here, ding, redirected back to Earth. Or it could be absorbed and it holds it for a while and then it's redirected to Earth. So methane and carbon dioxide interrupt that system. I'm trying to make this go away. Okay, so we have received a new email from the World Climate Institute. Remember, when we work in Amplify, they give us a role, and our role in this unit is student climatologist, and we are pretending to work for this pretend organization called the World Climate Institute. So from Irene Lee to student climatologist, subject helping others understand climate change. Thank you for all your hard work on the subject of climate change these last few weeks. Being able to explain why our climate is changing and why Earth's ice is melting is vital. Today, I'd like you to create a report that explains these climate change ideas to a general audience. Be sure your writing is clear and includes visuals so people who don't know much about this topic will find it meaningful. WCI hopes that if people understand, they will take action and support laws that will help with this serious problem. Your report is a valuable part of WCI's mission to educate the public so that they can better understand this topic. We appreciate your help. So to complete this writing assignment, you will open the document assigned titled Lesson 2.7 Assignment. You're going to end up turning this document that we were just working on in, and also don't forget to turn in your 2.7 assignment in when you are done. Do not turn in the key concepts assignment yet. You will continue to work on this assignment later, okay? So the only thing you had to do on this one basically was highlight your answer choice here. But now you're going to go to your assignment. It's in Google Slides that looks like this. It's titled Lesson 2.7 Assignment. Okay, here's the key for this assignment. We tried to make it as easy as possible for you guys, which means that we created a drag and drop option for this assignment. It's in a slideshow. You cannot go into present. If you go into present, then you can't move the things around. So you cannot go into present. You have to leave it like this right here. You can make it bigger if you want. Not quite that big. No. Okay. No, it's going to try to zoom in. There we go. Okay. So it says use the word bank on the right to fill in the blanks by dragging and dropping the words in the correct blank in order to complete the paragraph correctly. So remember, you cannot be in present mode when you have the slide in the right screen and you see it in the left here. That's where you want to be. So you're just going to pick up the boxes and you're going to drag them to where you think they belong. So if you think that number 1 is increase, you're going to drag and drop it there. If you think that number 2 is entering, you're going to drag and drop it there. I'll give you a hint, guys. I'm not giving you answers there, okay? So it's a drag and drop. You don't even have to type. You're just dragging and dropping it where you think those words go. So read it carefully. Make sure that it makes sense. This is for a grade, so make sure that it makes sense and make sure you get the words in their correct locations, okay? This is kind of explaining everything that we've learned so far. So an important assignment. Okay, that's for today. Make sure you turn this in. You turn in the document we were working in. Do not turn in your key concepts yet. All right. Thank you, everyone. Have a good day. Bye-bye.